Okay, greetings once again, guys, and welcome to another edition by iCampSA. In this edition, we're still looking at linear regression. We're looking at the 2018 November and June exam, and this is grade 12 statistics. So the 2018 November exam reads, a familiar question among professional tennis players is whether the speed of a tennis serve in kilometers per hour depends on the height of the player in meters. Furthermore, we are told the height of 21 tennis players and the average speed of their serves were recorded during a tournament. The data is presented in the scatter below. The least squares regression line is drawn, which is as seen here. And then the first question requires us to write the fastest average speed in kilometers per hour achieved in this tournament. So let's go ahead and have a look at 2.1. So if you look carefully, the speed is in the vertical axis. So if you look at the highest point is there. And if you look at the scale, we're moving in ones. So that would be 251, 52, 53, 54. So that means the highest speed there is that. So we can just note that, which is the highest speed is what we can see there, which is 251 kilometers per hour. Okay, that becomes our highest speed. Then let's now go to 2.2. Okay, so in 2.2 we are told consider the following correlation coefficients. So we're looking at 2.1.1. But let me quickly note something here. So if you look carefully, you are given as one of the coefficients as 0.93. So this coefficient is a strong positive correlation coefficient. So we have a strong positive correlation. Okay, and this strong positive correlation you would get such when your data is very close to the line. Okay, when your data is very close to your regression line. So you get such when the data points are very close to the regression line. Okay, and then you'll see that you also have an R value of 0.52. And this one here, it's very far from your 0.9. So this is a weak, but look at the R, it's positive. So it's a weak positive correlation. Okay, let's note that. So it's a weak positive correlation. So meaning when you draw your regression line, it has a positive slope, but really there's a weak correlation. So meaning the data points are very far from the regression line, right? Then if you look at the other one, which we given R, which is negative 0.42, this is a weak still because it's very far from either -1 or +1, but this is a negative correlation. Okay, so with this one, this is where what you would see is your line would be something like this, and then you have your points just, you know, being very far from the line and so on and so forth. Okay, so this would be the kind of situation that you are faced with that one. So now if we look at the first question, 2.1.1, which one of the given correlation fits the data that is plotted? So looking at the data that is plotted, we can definitely see that looking at this, the slope, we have a positive correlation. Okay, but also looking at how this data is related, we can tell that we have a weak correlation. Okay, so therefore we can take our answer. If you look carefully, we have 0.52, which is a combination of the two. So our answer here becomes C, of which C is R equals 0.52. 2.52. Okay, and then for 2.2.2, we are required to use the scatter plot and the least square regression to motivate the answer for 2.1.1. So already I've given the hints already, which is that we have a positive correlation. That's number one. So we can tell that we have a positive correlation. But secondly, we can see, looking at how far this data is from the regression line, we have a weak correlation. Why weak? Because the data points are far from the regression line. So if you look carefully, the data points are far from the regression line. So this is our motivation for why we have the case above. Okay, I hope that this does make sense. Let's create some space to answer another question here. Okay, guys, let's have a look at 2.3. So 2.3, we are asked, what does the data suggest about the speed of the tennis serve in kilometers per hour and the height of the player? So if you look at the data, you'll see that it's scattered. So there's no real relationship that we can confidently say that, let's say, for example, the taller you are, then the higher the speed. So what we can say is there is no conclusive evidence, or there's no evidence that the height of a player will influence their serve speed. So let's note that. So there is no evidence that the height of the player influences if you observe carefully, the speed of the tennis serve. So there is no evidence that this is the case because of this low correlation. Okay. So 2.4, we are told the equation of the regression line is given by 27 plus 0.7 bx. Explain why in this context the least regression line cannot intersect the y-axis. So let's think about what this means. So at a height of 0, that point means at a height of 0, we are going to have a speed of 27 kilometers per hour. That is what this means. So at x equals 0, what this means is that the speed of the serve, so a person who has a height of 0 will have a speed that is 27.07. But what we should note is that because we're dealing with x is 0, which is the height of a person, we clearly know that the height of a person cannot be 0. So therefore, this line should not intersect the vertical axis. So we can just make a note and say the height of a person cannot be 0. Okay, so our answer can just end there. We will not have a height of 0 as the height of a person. So done with this question, let's go to the next one, which is the June 2028 exam. So we are required to identify the outlier, but first we are told the table below shows the number of hours that a salesperson of a company spent with each of his 9 clients in 1 year, and the value of sales in 1,000 rands. So we are told identify an outlier in the data here. So if you look carefully, most of the data is just, there. But what you will see is we have one point that seems to be out of the norm, right? So that is that point. So 2.1, we can clearly note that the outlier is at, so I'll just write it as a coordinate. So if you look carefully, that's 100 and 100. So meaning the client spent 100 hours, or the salesman spent 100 hours with this person, and they were able to close a sale that is worth 100,000 rands. Okay, that is what we have. Now let's go to the next question, 2.2. Calculate the equation of the least squares regression of the data. So what they want us to do is we have y equals a plus bx. So what we are required to do is to figure out what is a equal to and what is b equal to. And in order for us to find this, what we always do is use your calculator. So let's quickly get our calculator up. Split the screen. So let's go to our calculator, shift 1. We want to put in a data set. Okay, so let's clear all of that. And this is the data. So let's go ahead. We'll start with x at the top, where we have 30, then 50, then 80, and then 100, 150, 190, 220, 260, right? Then we can go and put in the y. So that is 270, 275, 376, then 100, then 420, 602, 684, 800, and then 820. So I have more data. I need to figure out where did I go wrong. So we have 270, 275, 376, 100, 420, and then 602, 684, 800, 820. So let's look at the other one. We have 30, 50, 80, 100, and then after 100, if you observe carefully, we're supposed to have 120. So after 100, we are supposed to have 120. And then after 120, we need 150. And then 190, 220, and then 260. Right, that is what we have. So we are now in a position where we can go and read our values for A and B. So remember what I did was shift 1 and then stats reg for regression. Then I choose A. So you'll see that the value of A, which we find, is 94. I'll just use 3 decimal places, 503. Okay. And then let's look at B. B will be equal to, so shift 1, we choose B. So if you observe carefully, the value of B is 2.91. That will become A4. So therefore, our equation y equals, you will see we'll have 94.503, then plus 2.914 times x. So just to be sure that this is okay, so what I'm going to do is quickly check the r. Okay, so that is what we have. Okay, that's okay. Rounded up, it's 0.9. So that's our answer to this question. So let's go to 2.3. So for 2.3, we are asked we are told that the sales representative forgot to record the sale of one of his clients. Predict the value of the sales client if he spent 240 hours with him during the year, right? So essentially we're given X to be 240, and we are trying to figure out how much money would we have closed with this client. So what I'm going to do is to just use the equation. So we have 94.503 plus 2.194 into 240. Okay. So y will be equal to, let's go ahead, 94.503 plus 2.194 into 240. So what I end up getting is 621.063. Okay. So if we write our answer, we can now say that our prediction is 621,063 rands. So this would be the value of the sale. Okay. Value of the sale if the salesman spends this amount of time with the client. So that is about what we are approximating. So there's a mistake that I just made here, guys. I wrote 194 instead of 941. So let's quickly fix that. 914. So we have 914. Okay, so let me quickly fix that. So I wrote 149, so it's 914. So if it becomes 914, the value of the sale ends up being this here. So we end up getting about 793 and then 863. Okay, so the value of the sale will be 793,863 rands. Okay, so I hope that this does make sense. So that becomes the value of the sale. So let's have a look at the next question, 2.4, where we are asked what is the expected increase in sales for each additional hour spent. So if you think carefully, what we are looking at here is actually the price, change in price per hour for changing for every hour. So we're looking at the price per hour. Okay, so now if you think about this carefully, what this speaks to here is gradient, and our gradient for our problem is B. So you will see that our B value, which is equal to 2,914, this is bigger than 0. So meaning for every hour we are expecting to be making round about 2,914. So let's put that as our answer. So answer, and that is for every hour. For every hour what is the expected sales? So we can say for every hour the expected sale is what we just found here. So that's about 2,914 rands. Okay, so that is what we do expect, and this, guys, is what was expected to be done for this exam. So this brings us to the end of the question paper, and this is brought to you by iCampSA. So please share with others, and let's spread the gospel of passing. Cheers, guys.